Let's see what else. Why might a cell make lots of RNA, but only one copy of DNA? So, remember, DNA is the instruction book. If you start to make copies, sometimes it's going to be errors. Sometimes there's going to be things that are messed up. So the better way to do it is instead have lots of things to create your proteins instead of having lots of DNA. So another way to kind of say that is it's easier to have one recipe and a lot of cooks making that recipe versus having lots of different recipes and lots of different cooks making those in the same kitchen. It just gets messy. All right, number 3. So suppose our messenger RNA molecule that we had made in transcription has 300 nucleotides. Well, how many different amino acids could we get out of that set of 300, theoretically? So remember, in order to code for an amino acid, we need a certain number of bases. Let's take a look. Remember, we need 3 bases in a row on RNA in order to code for one amino acid. So for us, we're going to do some math for number 3. If we have 300 nucleotides or bases in our RNA, and we need 3 of them in order to make one amino acid, what is this going to equal? Let's have you guys put that down here for number 3. For number 4, what we're going to do is we're going to explain the connection between a codon and an amino acid. So remember, a codon is a set of 3 nucleotides that specifically code or identify an amino acid that needs to be used to create a protein. Now remember, all of these processes are done inside the cell. And sometimes we can have actual errors. So if it's an error of copying our DNA, we call that a mutation. So for us, mutations can create several different types of errors. One is it can create an error where that protein may not operate correctly. The error is so significant in the DNA that during the transcription and the translation process, we start to create a protein that will not function. Or it can have a slight change to our protein. Maybe we changed an amino acid, but it doesn't hinder its ability to function. And maybe it only slightly changed how it folds and is shaped. So we can have different types of drastic variation there. And then, of course, number 6, you guys can totally answer that one on your own. It's just a review of this GIF using our newfound information about matching information with our DNA, transcribing it, translating it, and creating proteins.